Hello students, welcome to Guru Gather English Medium Maths class. Probability is our today's lesson. What is probability? Probability is possibility of an event. Possibility of an event. There are some events in our environment. We can classify them as events that definitely occur. A fruit fallen down definitely occur. Getting a side after tossing a coin, you will have a side. Getting a side. Sun rising from west, that event definitely not occur. And remember my kids, there are some events may or may not occur. If you toss a coin, getting head, sometimes it may be or may not be. Getting head or getting tail. They are called random events. Random events. Right, we will see what is the definition of a probability or possibility. Right, you can see this lesson as 24th lesson in grade 9 textbook. By studying this lesson, you will able to, in this part we are going to discuss learning outcomes. What are the learning outcomes? By studying this lesson, you will able to identify random experiments. Random experiments. Then write the sample space of a random experiment. Sample space, very important word, sample space. Then identify the equally likely outcomes of a random experiment. Equally likely. We will see it. Then find the probability of an event in a sample space when the outcomes are equally likely. Outcomes means results. Okay. Then we are going to define a random experiment. What is a random experiment? As I told you earlier, there are some events that may or may not occur. Right? Getting 100 marks in your first term test. Sometimes it may be, otherwise may not be. Random one. Then experiment having following features are called random experiment. What are the features or properties? We will see. The experiment can be repeated any number of times under the same condition. Without changing the condition, you can do the experiment. You can repeat it. You can toss a coin. Next time also you can toss the coin. You can do it 5 or 6 times, 7 times, 10 times, 1000 times. Right? The experiment can be repeated any number of times under the same condition. Under the same condition means same coin, unbiased coin. You can't change the condition. Right? That is a property of a random experiment. Here, all the possible outcomes of the experiment are known before the experiment is carried out. We know that all the possible outcomes, outcomes means results of the experiment, are known before the experiment is carried out. You consider tossing a coin, you know the results, getting head or tail. If you rolling a die, you know the results numbered from 1 to 6. You may have 1 or 2 or 3 or 4 or 5 or 6. Before doing the experiment, you know about outcomes. Right? That is also a property. Can you understand? Yeah, that is also a property. Before doing the experiment, you know about the outcomes, right? Then the outcomes of the experiment cannot be stated with certainty before the experiment is carried out. Before doing the experiment, you can't find out the result occur at that moment, right? Therefore, the outcome of the experiment cannot be stated. You can't say certainty. You can roll a die, but you can't say my first result is getting 1. You can't say. You may have it. The next one, when the experiment is repeated, you can repeat the experiment. A pattern cannot be recognized in the outcomes. Consider tossing a coin. First time, head. Second time, head or tail. Third time, head or tail. Fourth time, head or tail. There is no any pattern. That is also a property of random experiment, right? When the experiment is repeated, a pattern cannot be recognized in the outcomes. Now, we are going to do some examples, practice problems. For each of the following experiment, select and write down random experiments, right? In this part, you have to remember the properties of random experiment. There are 4 properties of a random experiment. According to those properties, you can select random experiment out of the given experiments. Right, we will see. Rolling an unbiased tetrahedral die with its faces numbered from 1 to 4 and recording the number on the face which touches the table. Can you guess the outcomes? Yes, definitely. 1 or 2 or 3 or 4. But you can't guess the outcome certainty. First time, 1, getting 1. Second time, getting 2. You can't say. Therefore, this is a random experiment. Answer, random experiment. Second one, drawing a bead from a bag which contains bead of one color and recording its color. You consider there is a bag containing red beads. What should be the first one? Definitely occur. Red bead. Right? Definitely occur. Events that definitely occur. We know that that is not a random experiment. It means you can say first ball is red in color. Second one is red in color. Third one is red in color. No doubt. Therefore, that is not a random experiment. We will see, not a random experiment. Throwing a ball at a target and observing whether it hits the target or not. Sometimes the ball hits the target, right? Then this is a random experiment because you can't say the outcome certainty. Really, you can't explain the outcome, the result. Events that may or may not occur, may or may not, hits the target, right? Then answer is random experiment. Then planting 5 radish seeds that germinate in 5 days. Sometimes it may or otherwise may not. Events that may or may not occur. It means that is a random experiment. We will see. Answer is random experiment, right. Now, fifth one, read the question well. Read the question well. Checking whether a door opens when a key picked at random from a bunch of 3 different keys is used. Not same keys, different. Out of 3 keys, you have to find out the correct one or suitable one. First time you will have the correct key, or second time or third time, you can't say. Same, not same keys, different keys, no. Therefore, this is a random experiment. May or may not occur. Events that may or may not occur. Sometimes you may have the key, or otherwise you may not have the key. Random experiment. Answer is random experiment. Now, question number 6. Tossing a ball in the air and observing whether it falls to the ground. You know about the gravitational force. Definitely, it falls to the ground. Events that definitely occur. A fruit fallen down. Events that definitely occur. Therefore, this is not a random experiment. Not a random experiment. Now you know how to select random experiments out of the given set of experiments. Right. Very important word, sample space. Sample space. What is sample space? Sample space totally based on the random experiment. Outcomes. Total outcomes of an experiment is defined as sample space. To represent the sample space, we use capital S. My kids, what is the letter? Capital S. You remember that. Sample space. Okay, we'll see the definition. All the possible outcomes of a random experiment can be written as a set. Set means well-defined collection of elements. You know that there are 3 ways of representing a set: as a description, as a list, by a Venn diagram. Here you can list the possible outcomes. You can list the possible outcomes of a random experiment as a set. Possible outcomes means total outcomes of the experiment. This set, which consists of the possible outcomes of a random experiment, is called its sample space. Right. Write the sample space for the experiment of tossing a coin. What are the outcomes? Getting head or getting tail. How many outcomes there? 2 outcomes. If you consider this experiment, events that may or may not occur, therefore this is a random experiment. In a random experiment, you can find out the sample space. Sample space, capital S is the symbol. Set property. What is the set property? Curly brackets should be used. Elements should be separated using a comma. Set property. S is a set containing total outcomes. Therefore, this is called sample space. What is the meaning of H? Getting head. Getting head. T, getting tail. NS. NS means number of elements of the set. How many elements there? 1, 2. 2 elements. The definition, NS is number of elements of the sample space. Number of elements of the sample space. I suppose that you understood well sample space, total outcomes of a random experiment. Right, next one. Write the sample space for the experiment of drawing a bead from a bag which contains 3 red beads and 2 black beads. 3 red. How to mark 3 red beads? R1, R2, R3. Then 2 black beads. First one, second one, it means B1, B2. Considering 3 red beads as R1, R2, R3 and 2 black beads as B1, B2, you can write the sample space as a set, curly bracket, R1, R2. R1 means getting first red bead. R2 is getting second red bead. R3 getting third red bead. Getting first black bead. Getting second black bead. It means n s number of elements in the sample space is 5. Then write the sample space for following experiment. A bag contains 4 milk flavored toffees and 3 orange flavored toffees of the same size and shape. Same size and shape. That is the condition. Randomly drawing a toffee and recording its flavor. Events that may or may not be occur. We don't know certainty. We'll see what are the total outcomes. Considering 4 milk toffees M1, M2, M3, M4 and 3 orange toffees as O1, O2, O3. Now sample space, getting first milk toffee, getting second milk toffee, getting third milk toffee, getting fourth milk toffee, first orange one, second orange one, O third orange one. The sample space consists 7 elements, therefore NS is 7. Right, we'll see another question. Before doing questions based on sample space, we have to consider equally likely outcomes. Outcomes, total outcomes, sample space. Total outcomes means sample space. Now we are going to classify events equally likely, equal possibilities there, equal possibilities. If you consider a fair coin, getting head and getting tail are equally likely. Sometimes you may have head, sometimes you may have tail. How many total outcomes? 2. Getting head means 1. 1 over 2 is the probability there. We will discuss it later. Right. Equally likely outcomes. How to define it? Right. You can see, my kids, of a random experiment, if each outcome is equally likely to occur, then that experiment is called an experiment with equally likely outcomes. You will understand this one considering these examples. Consider the following experiments. Equally likely outcomes. The 4 faces of an unbiased tetrahedral die are painted in 4 different colors, namely red, blue, yellow and green, recording the color of the face which turns up when it is rolled. 4 faces, it means equal faces, equal number of faces. 4 faces of an unbiased tetrahedron. Unbiased, it means balanced one. Same balance in 4 sides. Right? Therefore, painted in 4 different colors. The possibility of getting red, the possibility of getting blue, the possibility of getting yellow, the possibility of getting green are same, equal possibilities. Therefore, what is this? Outcomes are equally likely, right? Next one, recording the number on the card which is drawn at random from 10 identical cards which numbered 1, 1, 1, 1, it means 4 ones. 1, 2, 2, 2, 3 twos, 3, 3 and 4. You know that how many ones here? 4. How many twos here? 3. How many threes here? 2. How many fours? 1. Not fair. Not fair. Different possibilities. 4 times you have 1. 2 times you have 3. 3 times you have 2. Different possibilities. Not equal possibilities. Therefore, what is this? Can you guess it? Yes, we'll see. Outcomes are not equally likely. Outcomes are not equally likely. Then we are going to define probability of an event when the outcomes are equally likely. How to define the probability? Already we have learned about sample space. Total outcomes of random experiment, sample space. Here, the probability of an outcome of a random experiment with equally likely outcomes is given below. We will see it. Probability of an outcome, we are consider about one event of an outcome. Only one result, getting head, one result, getting tail, one result, getting 1 after rolling a die numbered from 1 to 6, getting 2, only one outcomes, not getting even numbers. If you consider getting even numbers, 2, 4, 6, there are 3 outcomes. Getting odd numbers, 1, 3, 5, 3 outcomes. Getting a prime number, 2, 3, 5. Getting a composite number, getting a square number, more than one outcomes there. Remember that. The probability of an outcome or of an outcome of a random experiment. In this case, we consider only one outcome. Considering outcomes 1. Then what is the definition? Probability of a selected outcome, always in the numerator you have 1, then total number of outcomes in the sample space of the random experiment. This definition is valid for random experiment, right? Probability of a selected outcome 1 over, we know that probability means a fraction. Fraction. Probability of an event represented as a fraction. Fraction contains numerator and the denominator. Here you can see 1 of an outcome, 1. Number of outcomes we considered should be divided by the total outcomes. Now you can guess the definition of the probability. Here we considered of an outcome, right? Number of outcomes we considered in the experiment should be divided by total number of outcomes, right? We'll see the definition through this formula. We can see. Example, consider the experiment of rolling a fair die numbered from 1 to 6. What is the reason of getting fair die? We want to get equally likely outcomes. Equally likely outcomes we want to explain here, right? Then Faraday numbered from 1 to 6. How many numbers there? 1, 2, 3, 4, 5, 6. 6 outcomes. Total number of outcomes are 6, right? Then what is the sample space? Total outcomes of the experiment. Getting 1 O. What is the meaning of S is equal to 1, 2, 3, 4, 5, 6? This is a set. There is a meaning. Here there is a meaning. How to describe? This is an experiment. No. Experiment means you can describe well. 1 means not actually 1. Getting 1. Getting the side named as 1. Getting 2. Getting the side 2. The side named as 2. Getting 3 means getting a side named as 3. Getting 4, getting 5, getting 6. Collection of outcomes is called the sample space. Sample space means the experiment, right? Therefore, this is a random experiment. What is the next property? Equally likely outcomes, right? Probability of getting 1. As I told you earlier, probability of getting 1. How many outcomes in the numerator? 1, 1, getting 1. 1 should be divided by total number of outcomes in the sample space. It is clear that total number of outcomes 6, therefore 1 over 6. Next one, probability of getting 2. Getting 2 means 1 results, not 2 over 6. 2 is an event, that is a single event. 2 is getting 2, right? Then not 2 over 6, 1 over 6. Here some students may think that getting 3 is 3 over 6. Getting 3 means getting a side named as 3. That is an event. Therefore, how many elements there are? 1, getting 3. 3 is an element, 1 over 6. Then probability of getting 6. Sometimes you may think that 6 over 6. That is completely wrong. Remember that. That is completely wrong. Why is that? Getting 6 means not 6 elements there. Only one outcome, that is 1 over 6. Getting 6 means number of elements, number of outcomes 1, total number of outcomes 6. Probability of an event. Now we want to find out the possibility in the numerical form. As a fraction we want to express the possibility. As a fraction we want to express the possibility. Right? As a fraction means there should be a number in numerator, there should be a number in the denominator. We will see how to define the probability of an event. The probability of an event in the sample space of a random experiment with equally likely outcome is given below. We will see it. Probability of an event is equal to number of elements in the event. Number of elements in the event. If you consider element, you have to find out how many elements in that event. In an event, there may be one element or more than one element. Number of elements in the event should be divided by number of elements in the sample space. We can discuss with these definitions. NS. What is the definition of NS? Number of elements in the sample space. NS. Then NA, number of elements in the event. A, number of elements in the event A. Then PA, the probability of event A occurring. PA means probability of A, PB probability of B, PC probability of C. Try to get the pattern. Px probability of X, Py probability of Y, PA union B probability of A or B, PA intersection B probability of A and B. Understood it? Try to get the pattern using this definition, right? PA complement probability of complement A, probability of event A. You can change the event according to the experiment. In this case, we consider event A. Getting an odd number, you can name as A. Getting an even number, you can name as A. Getting a prime number, you can name as A. Getting a square number, you can name as A. Right? You can consider an event and you can name that as A. Right? Now, PA equals NA over NS. Here, my kids, can you see a pattern? A, AS, PA, NA. Now you tell me PB. Yes, you tell me PB. PB is NB. NB over NS. Always you have NS in the denominator. This is a fraction on the number A, below the number S. This is the definition. If you consider Px, how to write it? Px equals Nx over Ns. If you consider Pc, Pc equals Nc over Ns. Px, Nx over Ns. Likewise, you can name events. Right. Practice problem. Consider the experiment of rolling an unbiased. What is the reason of getting unbiased? Equally likely. Equally likely. Unbiased cubic die with its faces numbered from 1 to 6 and recording the number on the face that turns up. We are going to consider sample space of equally likely events. And here you can see this is a random experiment. Random experiment, equally likely events. Then the probability. Probability of random experiments with equally likely events. Right? It is clear if you consider this problem. Right. Now, write the sample space S of all the possible outcomes of this experiment. Sample space means total outcomes of this experiment. Right. We can see it. Capital S equals 1, 2, 3, 4, 5, 6. Getting 1, getting 2, getting 3, getting 4, getting 5, getting 6. Here, find the value of Ns. Number of elements in the sample space. Ns equals 6. Next question. If capital A is the event of an even number turning up, even number, numbers which are divisible by 2 without a remainder. That is the definition of an even number. What is our first even number? 2, second even number 4, third even number 6. Capital A is the event of an even number. Capital A is a set. That set contains 3 elements, 2, 4, 6. Right? And find NA, number of elements of A. Answer: A is 2, 4, 6, number of elements in A equals 3. Next one, find PA, the probability of A occurring. Right, we will see the definition. PA equals NA over NS. NA means number of elements in the event. You know that 2, 4, 6, 3 over 6. 6 is the number of elements in the sample space. Now you can simplify 3 over 6 as half using the knowledge of equivalent fractions. Using a same number, you can divide both numerator and the denominator. This is called the simplest form of a fraction, simplest form of a ratio, simplest form of a fraction. Right? This is an application of equivalent fractions. Right? 3 over 6. Okay. Then we can consider another question. Read the question well. In a bag, there are 3 red beads, 2 black beads and 5 white beads which are identical in all other aspects. Consider the experiment of randomly drawing a bead from the bag and recording its color. If you consider the total outcomes of this experiment, 3 red beads, 2 black beads, 5 white beads. Total number of beads 3 plus 2 5, 5 plus 5 10. Total number of elements there 2 plus 3 plus 5 10. 10 elements. Right? Number of elements in the sample space is 10. We will see what are the question based on this text. Find the probability of drawing a red bead. You have to pay your attention for number of red beads. How many red beads there are? 3. 3 red beads. Number of elements in the event 3. Divided by total number of elements in the sample space or NS. Here number of elements, it means number of red beads should be divided by total number of beads, that is 3 over 10. You can't simplify this one. If you want, you can express this one as 0.3, no problem, as a decimal. Usually it is enough if you put the answer as 3 over 10. Right. Next one. Find the probability of drawing a blue bead. Blue bead. Blue bead. Here you have red, black, white. No any blue bead. Empty set. Null set. Can you remember? Sets without having elements. Right? NA. A is an event, but A contains elements. Here you can say, find the probability of drawing a blue bead. Consider this event as capital S. Consider this event as capital X. X is a null set. X is a null set. No elements. Number of elements in a null set or empty set is 0. According to the definition, number of elements in the event should be divided by number of elements in the sample space. No any element. 0 over NS. 0 over number. 0 is divided by a number. What is the result? According to maths, result is 0. Right? Here we can see it. Answer 0 over 10. Number of elements in a null set 0 over 10. The result should be equal to 0. Find the probability of drawing either a red bead or white bead either red bead or white bead. Red or white. O means union, sum. O, A union B. Can you remember sets? A union B. Total number of elements in set A or set B. Sum of elements. Here either red bead or white bead. Red or white. You know that how many red beads? 3. White beads 5. 3 plus 5, 8. Here 8 over 10 is the answer. Right. Next one. Find the probability of drawing a black bead. Black. How many black beads? How many black? 2 black beads. 2 over 10, total number of beads 10. Therefore, 2 over 10 is the probability of getting a black bead. This is how we learned the probability. Right? Probability is a possibility of an event. As I told you, possibility of an event. How many types of events in this environment? There are 3 types of events. First one, events that definitely occur. Events that definitely not occur. Events that may or may not occur. In this chapter, we discussed about random experiments. There are some properties of a random experiment. The special property is you can't say the outcome certainty before doing the experiment. And we considered about equally likely outcomes, equal possibilities, getting head, getting tail of an unbiased coin, equally likely outcomes. If you rolling a die numbered 1 to 4, then getting 1, getting 2, getting 3, getting 4. If you consider a pair die, equally likely events. Then we discuss about the probability. Can you remember? Probability of a selected outcome. Selected outcome. Number of elements in the event 1 should be divided by total number of elements in the sample space. 1 over ns, that is as a unit fraction. 1 over ns, right? That is a unit fraction. Probability of a selected outcome, right? Then what is the theoretical definition of the probability? Total number of outcomes in the experiment is ns, no? If you want to find out the probability of A, PA equals NA over NS. And we did some questions based on theoretical probability. We suppose that you understood well about the probability. This is very important lesson in your term test exams as well as in your O-level exams also. Probability is a essential problem to you. Not only O-level, A-level also, there are some applications based on probabilities. Therefore, study well these concepts. Do problems, do more problems based on probability. Dedicate your time. Leaders are ordinary people with extraordinary dedication, right? Try to be a leader. We are here to help you. Guru Gedara is the place to develop your knowledge. That is the place to win your world. Always join with us. My kids, next day I'll be coming with a new lesson. Join with us. Goodbye to all.